So how do we distinguish a geometric sequence from an arithmetic sequence? Here's an example of an arithmetic sequence. 3, 5, 7, 9, ... And we know that this is an infinite sequence. The constant difference is 2. And we know that because if we take any two consecutive terms in a sequence, 5 minus 3, 2, 7 minus 5 is 2, 9 minus 7 is 2. The difference is always going to be 2. So this is an arithmetic sequence. Whereas in a geometric sequence, we have a constant ratio that's denoted by a small letter r. Let's say the constant ratio is 2, and the sequence starts with the first term is 1. 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So that's how you get the next term. You just need to multiply it by the constant ratio. And this is an example of a geometric sequence. We know that the general formula for the arithmetic sequence is a sub n equals a sub 1 plus n minus 1 times d. You can get any term in the arithmetic sequence by using this formula. For a geometric sequence, we have a sub n equals a sub 1 r raised to the power of n minus 1. So let's try to use this formula. Let's say we're interested to know the fifth term of the sequence, and we know that the fifth term is 16. This is our a sub 1, a sub 2, a sub 3, a sub 4, and a sub 5. So n is equal to 5. So a sub 1, let's plug in the values. A sub 1 is 1 times r, which is 2, raised to the power of n minus 1, which is 4. Let's write 5 minus 1 first. So 1 times a number is the number. And simplifying the equation, 2 raised to the power of 4. So that means 2 times 2 times 2 times 2. The exponent tells you how many times you have to multiply the base by itself. So 2 times 2 is 4, 2 times 2 is 4, 4 times 4 is 16. So as you can see, the general formula for the geometric sequence works. You can get any term in the geometric sequence using this formula. A geometric sequence is a sequence whose terms have a constant ratio, and an arithmetic sequence is a sequence whose terms have a constant difference. Let's try to answer some of the problems related to geometric sequence. Is the sequence 3, 9, 27, 81 a geometric sequence? We know that a geometric sequence has a constant ratio. To see if there's a constant ratio, denoted by a small letter r, if we divide the term by the preceding term of any consecutive terms in a sequence, we should be getting the same answer. In this sequence, this is our a sub 1, a sub 2, a sub 3, a sub 4. So if I want to take the first term and the second term, so a sub 2 divided by the preceding term, which is a sub 1, plugging in the values, we have 9 over 3. And we know 9 is equal to 3 times 3. We can cancel out 3, and the answer is 3. So we should get 3 if we divide. If this is a geometric sequence, the answer must also be 3 if we divide a sub 3 divided by a sub 2. So 27 over 9. We know 27 is 9 times 3. We can cancel out 9. This is also equal to 3. How about a sub 4? over a sub 3. So plugging in the values, we have 81 over 27. We know that 81 is 27 times 3 over 27. You can cancel out 27, and that's also equal to 3. Now, since there's a constant ratio, therefore, this sequence is a geometric sequence. What is the common ratio of the geometric sequence 32, 16, 8, and 4? So again, let's write the given. In this sequence, this is our a sub 1, a sub 2, a sub 3, a sub 4. To get the ratio, the constant ratio, we can take any term and divide it by the preceding term. So let's say we have a sub 2, let's divide it by the preceding term, which is a sub 1. And that's 16 over 32. So we can factor out 16 as 4 times 4. And 32 is 8 times 4. We can cancel out 4. We still have a common factor. 4 can be expressed as 2 times 2. 8 is 4 times 2. We can cancel out 2. And we have 2 over 4. 4 can be expressed as 2 times 2. And the quotient is 1/2. So if this is a geometric sequence, I should be getting 1/2. Let's try a sub 4 over a sub 3. So 4 over 8, we know that how that's equal to this expression right here. So the answer is going to be 1/2 as well. So 4 is 1 times 4. 8 is 2 times 4. We can cancel out 4. And the answer is 1/2. So the constant ratio of this sequence, of this geometric sequence rather, is 1/2. R is equal to 1/2. In the geometric sequence, x minus 2, 3x minus 6, 9x minus 18, what is the common ratio and the next term of the sequence? So since this is a geometric sequence, again, this is our a sub 1, a sub 2, a sub 3. So 3 terms are given in the geometric sequence. To solve for r, a sub 2 over a sub 1. So we take the second term divided by the preceding term, which is a sub 1. So plugging in the values, we have 3x minus 6 over x minus 2. We can factor out the common factor, which is 3. And this will be x minus 2. At the bottom, we have x minus 2. As you can see, there's a common factor. I can cancel out x minus 2. And the constant ratio is 3. So I know now the constant ratio. And to get the fourth term of this geometric sequence, so remember the formula, a sub n equals a sub 1 r raised to the power of n minus 1. So a sub 4 is equal to a sub 1, which is x minus 2. R is 3 raised to the power of 4 minus 1, which is also 3. So let's simplify the equation. We have x minus 2. This will be 3 cubed. And we know 3 cubed means 3 times 3 times 3. and that's equal to 27. So we have 3 times 3 times 3. Again, the exponent will tell you how many times you need to multiply the base by itself. So 3 times 3 is 9, 9 times 3 is 27, times x minus 2. By distribution, we have 27x, 27x, let me erase that, minus 27 times 2. 27 times 2 is 54. So this is the next term, which is a sub 4. And the constant ratio is 3. Okay, that's it for today. Bye for now.